Hi all. In this lecture, we will see an introduction to database management system. We will see some basic definitions, and also we will see four main characteristics of a DBMS. So, database is a common word that is used nowadays. So, everywhere we go, we can hear this word database. If you take a bank, if you want to withdraw some funds, or if you go to a library, or if you go to an reservation system, if you use an online reservation system, everywhere there is database. So it is a common word now we use. So if you go to a supermarket also, there is some database. So it is something that data is there everywhere, and we need to store that data. So for that we need some DBMS or database management softwares. So we'll see an introduction to this database. We have in earlier days, if you take the traditional application, it was mainly based on numerical and textual databases. So earlier databases were created to store only numerical and textual databases. Now it has been changed. Now we have internet, web, everywhere we have different kinds of data. So it is not like we have non-traditional data like post, tweet, images, video clips. Then for that we have big data storage systems or no SQL systems. Not only SQL systems, we have other systems also. No SQL systems in order to create the social media content. We use this thing for social media applications and all. And also we have big data storage systems. You have heard about this Amazon, Google Cloud. All these people provide cloud storage systems. Everywhere we are using this database. So this big data storage is used to create is created to manage data for the social media applications. Then we have cloud storage for where we can store programs, images, videos, and emails. Then we have multimedia databases. Then we have a geographic information system. If we want to store data about this weather or maps, if we want to analyze these maps, if we want to analyze satellite images, we have geographic information systems. Then we have data warehouses and online analytical processing. So these systems are used by companies to extract and analyze business information from very large databases. So they will have some huge amount of data in their data warehouse, and if they want some data, they have to use some complex technique to analyze those data and to give useful information. Then we have a real-time and active database technology where it is used in this control systems or industrial or manufacturing systems. We use this kind of thing. Then we have search engines where the internet where we search in the internet for some information. So all these are the applications now where we use this database. So database is an important part nowadays. So wherever we use, whatever we use, we have this database system. So we'll see some definitions, some basic definitions. So we have uh, we have already seen that database is used everywhere. So we will see what you mean by this database. So database, it's a basic definition. It is a collection of related data. So related data means uh, something which is related. It should not be an unordered data. There should be some relationship between these elements that are stored. So if, for example, if you are storing some student details, then we'll store the student name, university register number, maybe the student address, phone number, like that. So it is a collection of related data. And you have to see that data is a plural term. So data is the singular term and data is a plural term. You should not use data and all. Data is a plural term. So it is data. It's a plural. It's plural itself. Uh, datum is singular. Okay. So database is a collection of related data, and by data, what do you mean by this data? It is some known facts that can be recorded and that have an implicit meaning. For example, name. Name is a data. Name of a person. It is a data. A phone number or address. So all these things are a database. Data. So if we have a collection of related data, then we call it as a database. Okay, so we use this data even in a phone. We can say that the contact is it's a data. So we are storing name and phone number is, and sometimes mail ID is also stored. So it is a data. Then another term that we use is mini world. Mini world. So mini world, it is some part of the real world about which data is stored in a database, or we call it as universal, a universe of discourse. So, or mini world, universe of discourse or mini world. So mini world, it is some part of the real world about which data is stored. For example, if you are storing college data of college students, then it is a part of it is a mini world. So it's a part of the universe. So college is a part of the universe, and we are storing only data of some college students. Then we call it as that data of college students, or the college database is known as a mini world. College is known as a mini world. So it is some part of the real world about which data is stored. So if we are storing data of college students, then college is a mini world. So then database, what do you mean by this database management system? So we'll see what do you mean by this database management system. Before that, a database, it is actually a logically coherent collection of data. We can say that it is a logically coherent collection of data with some inherent meaning. So it is a collection of some data with some meaning. Meaning will be there. Some meaningful information will be there. Well, we should not show some random data. It should have some implicit meaning, or inherent meaning should be there. So database management system. What do you mean by this DBMS, database management system? So we have seen what is database, what is data. Next, what do you mean by this database management system, DBMS? So it is actually a software. DBMS means it's a software package or a system to facilitate the creation and maintenance of a computerized database. So it is a computerized system that help the users to create and maintain a database. So it is a general purpose, or it can be called as a general purpose software system that helps in creating all this database system. Then another definition is a database system. What do you mean by this database system? So we have seen database, data, and DBMS. Next is database system. So database system means it is database management software plus the data. So if we store some data in the DBMS software, then the whole system, it is known as database system. So you should differentiate between these two, DBMS and database system. So DBMS is actually the software package or the system to facilitate the creation of all this thing, and database system means that software plus the data that is stored, then together it is known as a database system. So this is the basic database system environment. If you see this together, this is the software, DBMS software. There will be some software to process some queries. So I'll start from here. So we are the users or the programmers of the database. So we use some application programs or queries. So if you go to an ATM, you can see that application program running in the ATM system. So you have to press some, you have to touch the keypad, or you have to press something on the keypad. You have to touch the screen. Then, so that is the application programmer queries. So you will be checking your account. So that is, those are the queries. You are checking the balance of your account. Then those are known as queries. Then what you do is the software, there will be a software inside this DBMS software. That software will process these queries, and there will be software to access the stored data which is stored in the secondary medium. It may be in the hard disk or in the cloud. So it will be stored, that that data will be stored in the database. And we have another store database which we call it as metadata. So it is actually the data about this data. So we have actually store some data and we need to store the data about this data. We call it as metadata. So it is also stored in the secondary storage. So this together is known as the DBMS software, and we here it is a database system. So it is the application program plus DBMS software plus data that is being stored. All together it is known as the database system. So this is a general database system environment. So database management system, we have already seen, it is a collection of programs that enables users to create and maintain a database. So it is a general purpose software that facilitates the process of defining, constructing, manipulating and sharing databases among different kinds of users. So we can say that it is a general purpose software that facilitates the process of defining. We can define a database, we can construct a database, we can manipulate the database, and also we can share the database among various users and various applications. So what do you mean by this defining? Defining means we will be specifying the data types, structures and constraints of the data to be stored in the database. So we will be specifying the data type. What is the data type? So if you want to store the student information, so name, it should be some characters. Phone number, it should be a 10-digit number. Like that, we will be specifying the data type, the structure and constraints of the data. We call it as defining the database. So defining is possible in a DBMS software. Then another term we have used is metadata. So I have shown that metadata, it is actually the database definition or description. We call it as database catalog or dictionary. So we store information. It is a database definition or descriptive information that is stored in the database. So we will be storing information about this data. So what we have defined, what type of data that is being stored. So all those information will also be stored. It is known as metadata. So it is a data about data. So we will see all these things later. Dictionary, what you mean by this data, dictionary, catalog, all these things will be studied later. Then what do you mean by this constructing? So constructing is actually the process of storing the data on some storage medium that is controlled by this DBMS software. So it is actually storing in a secondary storage device or in some storage medium. It may be cloud or anywhere somewhere it will be stored. So then manipulating. So manipulating, it is actually querying the database to retrieve a specific data. Maybe it may be an updating the database, or it can be some kind of data that is to be, if we are checking the balance, then that is known as manipulation. We will be manipulating the database. Or if we want to check whether a book is available in a library, so all those are known as queries. So querying the database is known as manipulating. Okay, or if we want to change the phone number of a person or address of a person, all these are known as manipulating the database. Then fourth software that will be there, DBMS, is sharing. So it will allow multiple users and programs to access the database simultaneously. So multiple users and programs can access the same database simultaneously. So that is an important thing. Sharing should be there. So if you are using an online e-commerce site, if you are using an e-commerce site, you will be using, you will be buying some mobile phone from that. There will be some flash sale and all. So they will be maintaining that mobile phone item will be accessed by millions of people at a time if there is a flash sale at all. So all those people, multiple users should be supported. All those multiple users will be accessing the same program and the same database. So that simultaneous access should be done by this DBMS software. Then we have other features that are to be included in the database. There should be protection and security mechanisms to prevent unauthorized access. Uh, nobody should there should not be any malicious access in the database. Then active processing to take internal action in the data, or if we want to move some from data from one location to another, or if we want to do internal some matters, all these things should be supported in the DBMS. Then presentation and visualization of data is needed. Different users will need to be presented that data in different forms, so that database DBMS software should have some that presentation and visualization of the data that capability. Then maintaining the database and associate programs over the lifetime of the database application. So we need to maintain the database. We need to do some maintenance activities, like if we want to take backup of the database, or we have to check whether the unauthorized access has been reported, like that. All those maintenance activities are also need to be done. So that maintenance activity, maintaining the database, that support also should be there in the DBMS package. Now we will see an example. So this is an example mini world. So university is an example for you mini world. If you are storing data about that university, then university is known as a mini world because it's a part of real world. Then if we take entities, we will learn about this entity and all later. So these are known as entities: student, courses, sections, departments, instructor. All these are known as entities in the database, and there will be a relationship between these entities. Sections are, then students take sections, courses have some prerequisites courses, and instructors teach some sections. Courses are offered by department. So these are some relationships between these entities. Just an example. So this is an example of a database. We have student. These are the attributes: name, student number, class, major. So these are the different rows or the elements that are stored. This is another relation: course, section. So we have other grade report, prerequisite. So this is an example of a simple database. Next we will see characteristics of the database approach. So there mainly we have 4 characteristics of a database. We will see each one separately. First one is, so we will be comparing this database approach with a traditional file system. So before database came, we were using these files. So you might be familiar, while you write C programs and all, you have been using this file. You will be creating a text file, or you'll be storing some data in the text file, and we'll be opening or writing, reading that for those files. So we'll be comparing this database with the traditional file system, traditional file processing system. So if there was no database, we had to store all this information in the file. So if you want to store a student information, you will be creating a record for that student. You will be using some structure and all in C programs, and you will be storing it in the database, in a file, and you will be accessing those files and all. So we will be comparing this database with files when you say about the characteristics of a database system. So first characteristic is self-describing nature of a database system. We will see this separately. Then second characteristic, it is insulation between programs and data abstraction. Then support of multiple views of the data, third characteristic. Then fourth one is sharing of data and multi-user transaction processing. So we will see first one, self-describing nature of a database system. So this is the main characteristics of a database system. So we have already mentioned about metadata. So database system contains not only data, not only the database itself. So if we take the database system, it not only contains the database itself, but also a complete definition or description of the database structure and the constraints on the database. Or constraints means some conditions on the database. So database system contains not only the database, but also the complete definition or description of the database structure and constraints. So that is meant by self-describing nature. So if we take a database system, it contains data. Additionally, it contains a description of the database structure and the constraints on the database. Okay. So, for example, if you have some data for called phone number, we will specify a constraint. It should be a number, or it should be a 10-digit number. Then that is a constraint on the database. So that will also be stored in the database system. So that is why we say it is as a self-describing nature. It contains data about its data. So we call it as DBMS catalog. We store all this information in a DBMS catalog. So it contains information such as the structure of each file, type and storage format for each data item, constraints on the data item. So all these information will be there. So when we create a database, for example, if we are creating a college database, so we'll be storing the data and also we'll be storing the structure of that database inside it. So that is stored in the DBMS catalog, or we call it as data dictionary. So we'll be storing it in the dictionary, database dictionary. So it contains information such as structure of each file, type and storage format of each data item, and constraints on the data. So information stored in the catalog is called metadata. We call that data as metadata. It is data about data. So it describes the structure of the primary database used by the DBMS software and also by database users. We will see who are the different types of users and all later. So it describes the structure of the primary database, and also it is used by the DBMS software and also by different types of users. And it also lets you know the structure of the files in a specific database. So if we want to know the structure, how it is stored and all, it is also available in the DBMS catalog. So this is the metadata we have already seen. We will be storing the database definition also. What all data is stored, what type of data, what is the structure, what is the storage, what is the different type, what are the constraints, all this information will be there in the metadata. So this is an example for a catalog. So if we take the previous example, these are the different relations. Then student has 4 columns, course has 4 columns, like this. So it contains 4 columns. Then each column will be mentioned like this: name, it is of character the type, and it belongs to student number, it is character of 4 characters, and it belongs to the relation, like this, all this information. So this is an example for catalog, or this is known as metadata. Then second characteristic. So if we take the second characteristic, it is known as insulation between programs and data. So in the traditional file processing system, all the files will be embedded in the application program itself. So if you are using some program, it will be embedded. So if you have a supermarket software, in earlier days, if you are not using database, then all the information will be stored in the files. So what happens is that all the data files will be embedded with the application program. So what happens is, if we want to change something in the file, we need to change the application programs also. So if we want to change the application programs, then we need to change the files also. So that was a problem with the file processing system. But in DBMS, it allows changing the data structures and storage organization without having to change the DBMS access programs. That is, without changing the application programs, we can change the database structure. If we want to change data structure, or if we want to change the storage organization, or if we want to change the storage medium itself, everything is possible, because there is no relation between this application program and DBMS. It is treated as 2 different entities. So we can change one thing without changing the other thing. That is where we call it as insulation. So there is an insulation between programs and data. In traditional file system, it was not there. So structure of data files is stored in the DBMS catalog separately. That is why we store a catalog separately. So if we want to change the structure of the data files, we need to change the DBMS catalog only. So we don't need to change the application programs. So we call it as program data independence. So this is known as program data independence. So program and data are independent of each other. We can change program without changing data, and we can change the data without changing the program. So it is known as program data independence. So if we take object relational systems, object relational database, we will be seeing about it. Object oriented or object relational database system, we have program operation independence also. So if you have studied this object-oriented programming, or where you have studied this method, so method or function or method, so it is actually that function or method is known as a operation. So there will be a program and operation independence will be there. When you want to access some in object database and all, if you want to access something, you will need a function or method to call it. So it will contain an interface which includes a name and also the data type or arguments or parameters. All these things will be there. So if you want to change that method or operations or functions, it is possible without changing the affecting the program. So that is known as program operation independence. So we have program data independence, and in the case of object databases and object relational databases, we have program operation independence is there. And we call together, we call it as data abstraction. Data abstraction. So the characteristic that allows program data independence and program operation independence is called as data abstraction. Data abstraction, we can say that hiding the internal details from the external user, that is known as data abstraction. So we'll be hiding everything. So if you go to an ATM, you will be aware of the database, where the database is stored, where that storage medium is. Nothing you will be. Or if you are accessing some online reservation system, you are not aware of area of the database. So that is known as abstraction. So we'll be learning about this data model, conceptual data model and all. You will see what is this data abstraction. So data abstraction basically means it hides the internal details, or the storage or implementation details is hidden to the external user. We need not understand what is happening inside. So it is hidden. So database is the thing that hides all this program and data. Then third characteristic of database is support of multiple views of the data. So if you take a database, we have different types of users. If you are using a banking software, or if you go to a college library, that college library has different types of users. There will be student users, there will be faculty users, there will be library officers, or library there will be some library managers. So they will have different views of the same data. You will be allowed to search for a book item, so you won't be allowed to renew that item. So that renew option will be available only for the librarian. Or if you want to delete a book, it is not possible for an ordinary user. Only admin can do that. So a database supports multiple views of the same data. So different types of users will require different views of the data. So users may require different perspective or view of the same database. Or if you are using a banking software, there are different types of users. There will be a manager, there will be officers, there will be clerks. So they will have different views of the same data. So some privileges will be given to only higher authorities. So we can if we are using this DBMS, we can support this kind of multiple perspective or multiple view of the same data. So a view, it can be defined like this. A view may be a subset of the database, or it may contain a virtual data that is derived from the database files, but it may not be explicitly stored. So it is actually a subset of the database, or it may contain a virtual data that is derived from the database, already existing data files. We will be deriving something and it may not be explicitly stored. It may be just to show some information or like that. For example, if we I'll show some example. So a database must provide facilities for defining this multiple views. So that is another characteristic of a database. So this is an example for view. So if you look at this transcript, so these are actually virtual views. Actually, this data is stored in different data tables or different relations. So, and when we want some transcript information, all this data will be combined, and we'll get a view like this, or prerequisite for all the courses. So this is actually, the data is not stored like this. So this is just a virtual view of the original data. So this information is got from different tables. Actually, student may be present in the student table, course may be present in the course table, grade information will be there in the another table. So all these tables will be combined, and you will get a view of like this. So this view is provided by the DBMS software. So we can have this kind of different types of views when we use a DBMS software. Then fourth characteristic is sharing of data and multi-user transaction processing. So a multi-user transaction processing means multiple users should be allowed to access the database at the same time. So multiple users should be able to access the same database. So you are aware of this thing. You will be using the online. If you are using a online reservation system, multiple people, multiple users from different locations will be accessing the same reservation. If you are booking a flight, or if you are booking a train ticket, multiple people will be accessing the same database. So our database should support that kind of thing, and there should be some concurrency control software. So we need to control this concurrency management, because different people will be accessing the same data element. Then if we are not providing any concurrency control software, then the data will become inconsistent. Wrong information will be provided. So that concurrency control mechanisms will be provided by the database software. So if you are taking this online transaction processing, like the airline reservation system, different people will be using this thing. All these applications require this multi-user transaction processing. Mm, So what do you mean this transaction? So it is actually an executing program or process that includes one or more database accesses, such as reading, updating database records. So all these are known as transactions. So there will be different transactions at a time. So people will be using different types of transactions on the same database. So if you take same database, different, for example, some people, if you are taking an e-commerce site, and if you are trying to buy a mobile, one person will be trying to buy a mobile, one person would have added to the cart, some person will be deleting the item from the cart, some person will be doing some payment on that mobile. So all this concurrency control, so all these are known as online transaction processing. So when we do this thing, we should have some concurrency control software in the database. So our database should support this thing, sharing of data and multi-user transaction processing should be there. So this is a reference. We'll be following this text, 6th edition. I have taken from 6th and 7th editions of Elmaster and Apathy. Thank you.